Hello everybody, this is Andrew with the Robotis Customer Support Team YouTube channel, and today I want to go over how you can use the Robotis Arduino examples from the DYNAMIXEL Shield and DYNAMIXEL 2 Arduino libraries to change different settings in the firmware of your DYNAMIXEL. So today we're using the DYNAMIXEL XM430-W210T, and that's being used along with the DYNAMIXEL Shield for the Arduino MKR series, and an Arduino MKR0 board. So you can see those in the background right behind the servo in the right side of our screen here. And it's a pretty common question that we get from users who are interested in changing different settings of their servo, but not quite sure how to go about doing that without starting up a piece of Robotis software. And I wanted to go over my recommended example, and this is available in the DYNAMIXEL Shield libraries for the Arduino Uno. So let me go ahead and open this up. And this is going to be found under File, Examples, and DYNAMIXEL Shield, Advanced, and then read_write_ControlTableItem. So this is a really useful example. It actually is configured to work with any model or series of DYNAMIXEL, so you can use it with a DYNAMIXEL Protocol 1.0 model or Protocol 2.0 model. So today we're using the Protocol 2.0, but there's just a couple things you'd need to change to use it with 1.0, and I can link a recent tutorial video we made in the description of this video to help you understand the firmware settings to change. Let's go over the basic functionality of this example. So here we can see this example is using the DYNAMIXEL Shield libraries, and that's meant to run on the DYNAMIXEL Shield for Arduino MKR series, as well as the DYNAMIXEL Shield for Arduino Uno. So the first thing you can see in this example is that it gives a very long list of what it calls control table items, and it says both 1.0 and 2.0. So this is something that will require you to pay some attention. You always want to make sure the control table item that you're going to use with this example is the exact name of a control table item that you can find in your DYNAMIXEL firmware. And if you're ever not sure of the control table names in your DYNAMIXEL firmware, we can go ahead and check that on the Robotis e-manual. So again, the e-manual is emanual.robotis.com, and this is the home page here. To find your model of DYNAMIXEL and check the firmware, click on DYNAMIXEL, and then scroll down to your model. So today we're using the XM430-W210T, and I think I just passed it here. So XM430-W210, you don't need to worry about the lack of a T or an R. These are going to be the same manual for either variation. So to check the firmware settings we have here, you would scroll down to the control table, and here you can see the exact name of all your firmware settings, as well as the acceptable range and the unit values that these equate to. So let's continue looking over at the Arduino example, read_write_ControlTableItem. We can see that it basically starts out with a few definitions for different Arduino boards, and then it will go on to define the start of the example. This is going to be one of the main things you want to make sure to confirm while working with this example. You need to make sure your DXL_ID variable is equal to the same ID number you're using with your DYNAMIXEL. So today I've already confirmed that the DYNAMIXEL in our video here is DYNAMIXEL ID number 1. Aside from that, you are also going to want to confirm two other lines in this, and those are going to be DXL.setPort version and DXL.begin. So DXL.setPort version is going to define the protocol version of the DYNAMIXEL you're working with. So you will need that to match your model of DYNAMIXEL, and the DYNAMIXEL X series is a Protocol 2.0. And then DXL.begin will set the baud rate of your serial bus. So we're using 57,600 today. So to go look at the basic function of the example, what we have here is the example starts by turning on the torque of the DYNAMIXEL, and then actually setting the DYNAMIXEL to what is a velocity control mode. Or actually, it looks like the comment here is slightly inaccurate. So what this example does is turn off the torque of the DYNAMIXEL because it sets this to 0. And that's actually a prerequisite before you can change the operating mode of your DYNAMIXEL. So when you're using this example with whatever model you're using, you're going to want to focus on the lines that are commented to be for the model that you're using. So today we're working with the DYNAMIXEL X series, and I'm going to be focusing on only the lines that are labeled as MX 2.0 and X series. So the right control table item torque enable, torque off is universal. However, what it does next is that for the X series, it sets the operating mode for the DYNAMIXEL IDE that we defined earlier to operating mode number 1. So in order to understand what's happening here, if we go to the operating mode firmware of the DYNAMIXEL XM430W210, we can see that setting that to 1 sets it to velocity control mode. So that means that the DYNAMIXEL is going to spin endlessly with the default Arduino example. For the AX and MX series and the XL320, it also sets them to endless turning modes using their own firmware settings as well. But let's move on. So after turning the DYNAMIXEL to velocity control mode, what it does is if you look at the MX 2.0 and X series section of the example, is that it writes a goal velocity to the DYNAMIXEL and then reads the present velocity of that DYNAMIXEL out to the serial monitor. It applies a short delay. Again, we're skipping over AX, MX, and XL320. And then next, for the MX 2.0 and X series, it writes a new goal velocity, which is 0, so it's going to stop the DYNAMIXEL. It delays for 500 milliseconds, and then it reads the present velocity of the DYNAMIXEL out to the serial monitor. So let's go ahead and try that now. First, you always want to make sure that you have the correct board set, as well as the correct port for that board. And I'm going to go ahead and click Upload. Alright, now we can see that the DYNAMIXEL has started moving, and if we open up our serial monitor here, we can see that it is just printing the raw values of its present velocity, both during its motion and while it's stopped. So, moving, 200, stopped, 0. So this just shows you a very basic function of the DYNAMIXEL. But what if you wanted to use this example with the DYNAMIXEL in a position control mode, for example? We can do that pretty easily by just editing the example here. So if it doesn't bother you, the DYNAMIXEL is just going to keep running until we change something else on it, because the Arduino, of course, is going to loop its code. So here we go. If we want to change this example to position control mode. So we're going to go back here where it says set velocity speed mode. And we learned earlier that right control table item for operating mode, 1 equals velocity control mode. If we go back to the firmware of the DYNAMIXEL, and we see we're still back on this operating mode description here, we can see that the position control mode is equal to a value of 3. So if we want to use position control mode, we're going to have to write a 3 there. So let's go ahead and open that back up. And for position control mode, let's go ahead and edit this to 3. And so now this should be position mode. But again, this would only be on the DYNAMIXEL X series side. You would have to change different settings if you were working with AX, MX, or XL320. But here we go. Operating mode is going to be number 3 now. And in position control mode, it is important to note that the DYNAMIXEL is not going to be looking for a goal velocity command like this example was setting by default. For position control mode, we're going to actually need to send a goal position command. So we're going to need to change the values that we're writing later in the firmware to see the DYNAMIXEL move correctly. So if we go down to the loop of the code, we see here MX 2.0 and X series. We're writing the goal velocity, and we're setting that velocity to 200. We don't want to use goal velocity today. We want to use goal position. And let's confirm and make sure that's in the list here. And we can see we have goal position right here. So let's go ahead and use goal position. Oh, we need to make sure it's capitalized the same way. And it turned blue, so that confirms that it is valid. And let's have the DYNAMIXEL move from basically its minimum position to its maximum. Wow, my mouse is kind of wigging out. All right, so if we're going to goal position, position 1, then we're going to have the DYNAMIXEL reading its present velocity back to us, which is okay, but it could be better. So let's actually have it read the position that it reaches back to us instead. So if we write present position, which again is another firmware address that is listed up at the top of this example. If my screen would move smoothly, we can see here present position. And so now here we have our first portion of the code changed to goal position and present position. And so instead of setting goal position to 200, we're setting it to essentially the minimum, which is 1. I believe technically 0 is the minimum. And now let's go ahead and send it a different goal position to move to so we can see it moving back and forth. So we have the first one here, then we ignore AX, MX, and XL320. Then delay, and now we have the second statement here. So if DXL.write ControlTableItem, goal velocity, we don't want goal velocity again, we want position, so goal position. And here it's writing goal position to 0. We don't want to move to 0 just because we moved to 1 earlier, so let's send it from the minimum to the maximum. So let's go ahead and send it to 4095. So that's going to be moving from the absolute minimum position range to the maximum. So you're going to see it move from the bottom right to the bottom left, essentially, when I start this example. And let's go ahead and update present velocity to present position. And that should be good. So we're going to just see a change in this example. Instead of the DYNAMIXEL turning in one direction and then stopping, we're going to see it move all the way in one direction, then all the way in the other direction, and then report its position every time it does that. So now let's go ahead and upload this example. And there you go. You can see the DYNAMIXEL's changed the way it's moving now. Let's check the serial monitor. Alright, so we're getting different values that look like they're positions. Interestingly, they're not the full positions that we have set in the example code here, and I'm pretty sure I know why. So the code will read the position at the exact time that delay finishes. And essentially, after writing the goal position of the maximum or the minimum, the DYNAMIXEL starts moving, and then 500 milliseconds later, it reads its exact position at that point in time. And then it tells you, hey, I'm at 2,543, I'm at 1,557, 2,543, and so on. So let's see if we can update that and make it a little bit more accurate looking by just increasing the delay before we read that position. Let's make it a delay of 1,500, just for fun. So that should be, what, approximately 1.5 seconds. And so I changed both of those delays there, and I'm going to upload that code. And here we can see the DYNAMIXEL is still moving. It's doing it a little bit more slowly. And here we go. So now we're actually getting position ranges that are much closer to the positions we're setting. It looks like it's stopping maybe just about one step shy, but again, that's something that you can easily tune using the PID gain controls that are in the DYNAMIXEL firmware. And again, one step shy is extremely close, considering the resolution of the DYNAMIXEL steps are 0.088 degrees. So that's 0.088 degrees away. So we're incredibly precise here, and the precision can be increased further as well. But so let's say we want to go one step farther now. We've changed this example to use a position control mode instead of a velocity control mode. But for example, let's say that we want the DYNAMIXEL to move more slowly while it's completing this position command. So there's a number of firmware settings in the DYNAMIXELs that you can use to do this. One of the simpler ones and one of the more popular settings, I would say, just because it's really useful, would be a setting known as profile velocity. So profile velocity actually allows you to set the maximum velocity that the DYNAMIXEL is going to reach while it's moving. And that's measured basically using the units that we report in the firmware table here. So profile velocity, it's also address number 112, has a range of theoretically 0 to 32,000 and something, but each of those is equal to 0.229 RPM. So if we want the DYNAMIXEL to move more slowly than it's moving now, we can actually set a value to profile velocity as well. So let's do that by adding an additional, basically write ControlTableItem command to this example. So I'm just going to go ahead and add into the existing loop here. So we have dxl.write ControlTableItem goal position. So without being very picky about when I'm writing this value, I'm just going to add in a statement under the goal position statement here. So if we add another statement for dxl.write ControlTableItem, we can then use the profile velocity setting, which if you look up here, in addition to the DYNAMIXEL firmware and the e-manual, we have it listed somewhere. We have it listed right here. So profile velocity, there's also a profile acceleration. That might be a topic for another video. And then let's go back to this line we're writing. So profile velocity, not plus, but we want underscore, DXL ID, because that's the DYNAMIXEL ID we're commanding, and let's set that to, let's say, about 100. So 100 times 0.229 RPM, so we're going to limit this to about 22, 23 RPM. Or let's go ahead and actually make it a little bit slower just so it's obvious and pretty dramatic. Let's make that about 50. And that's really all you need to do just to see the change in the setting. No, wait, let's not forget our semicolon. But let me just show you how this affects the motion here. All right, so now you can see that it's very different here in the motion. So what's happening here is you can see that it's moving much more slowly, but again, the code is continuing to read at that same speed it's been running at. So it's sending its position commands back and forth, but it can't quite travel fast enough to reach the second position. Let's see if we add in a little bit more delay. We can see how that will change that. Let's make that 2500 4,000, and 2,500. So almost enough time, but you can see basically what's happening. So now it has almost enough time to reach that full position. So let's go ahead and make that a little bit faster. And let's say, for example, you wanted to, let's use the acceleration settings as well. So let's make our velocity about 200, just so you can see how that changes it. So first, this is just so you can see how the faster velocity affected it, and now we're much closer to our original speed. And see, we still get the position output that we were receiving before. Now let's go ahead and just add in one more command, and let's make a command for profile acceleration so you can see how that affects the motion. So of course, profile acceleration will apply a certain amount of acceleration to your DYNAMIXEL. So it won't reach that full profile velocity immediately. And let's just start out with, 50. And let's not forget our semicolon. And then let's go ahead and update and add this. So now you can see it is applying a certain amount of acceleration, so it's speeding up and slowing down. And if we want to make that a little bit more drastic, let's go ahead and reduce that acceleration. Let's make that about 10, just so you can see how much that can change the motion characteristics of the position. Or I should say of the position seeking. And there we go. That gives you a very smooth acceleration and deceleration while it tries to ramp up to the full profile velocity speed that we set in the middle. So motions like this can be really useful when you're, obviously want a smooth motion and you don't want to jostle your payload or your attachments too much. Hopefully you enjoyed this video and it gives you some idea on how you can use the Arduino examples to interact with the firmware of your DYNAMIXEL. So we hope to see you next time, and please remember to like and subscribe to continue supporting us making these educational content for DYNAMIXEL servos. We hope to see you again.